So hi everyone, my name is Juliette Lavoie. I'm a climate services specialist at Uranus in Quebec, Canada, and I'm also the technical co-lead for the Fresh Eyes on CMIP group. So Fresh Eyes on CMIP is a group that wants to include more early career researchers in the CMIP community, and we have a bunch of different projects. I'm going to be presenting one of them today, the CMIP 6 data usage report. This project was co-led by me and Lisa Ziegler, and all these wonderful people that are written on the screen worked on it also. But we also got a lot of help for other members of the CMIP community, getting data, getting feedback. So thank you to everyone. So can you change? Is the slide changing? Yes. Okay. A bit of context, newsflash, there is a lot of CMIP6 data. More than 16 petabytes of data was produced in CMIP6. This is downloaded around the world by a lot of different types of users. So there are scientists, but there's also a lot of decision makers that are using CMIP data, even some commercial use. And people are downloading this data from multiple different sources. And so the goal of this project was to analyze existing statistics of the downloads from ESGS, gather statistics from other sources where people are downloading this data, and put it all together in a report of global pattern usage of CMIP6 data. And so what are these different sources? Of course, we have ESGF, the Federation of Nodes, where all the modeling centers are uploading their data and people can download from there. This is like the main place. But people are also downloading data from other places. So Pangeo is creating a subset that is hosted on the cloud. So there's an Amazon bucket and a Google bucket where there are a NetCDF version and a ZAR version. It's also possible to download CMIP6 data from Copernicus Climate Change Service or C3S. And there are copies on institutional servers. So some of the ESGF nodes also act as data pool for users in their institution. So people can just like directly reach the data, and that's not really counted as a download. And it can also be, when I say institutional copies, I mean another institution that is not an ESGF node can download it once on their server, and then different users can use it, but we're kind of only seeing this as one download from ESGF. And finally, there's also all the downstreams data set. So this is not directly CMIP data, but that's definitely CMIP information that is being used. That can be in dynamically downscale data like Cordex, but it can also be statistically and bias adjusted data that is often used by a lot of decision makers when we get a bit further away from science. So for example, at my organization, we download from ESGF some CMIP data and we do some bias adjustment that are then being distributed by a bunch of different users, but all of these users are not really counted in this one download from ESGF. So that's still part of like the overall usage and the value of CMIP data. Unfortunately, for the last 2 points, we looked everywhere. There's no data. For the downstream, for Cordex, there's a little bit of data, but we're not including it here. For the bias adjusted and statistically downscaled data sets, there's not even a list of everything that exists. So there's like a lot of things that is not counted. And all the copies on the institutional servers, we're not really able to know how many people are using them. And so for this presentation, I'm going to focus on the first 3 points, and I'll start with ESGF. So for ESGF, they are the folks at CMCC that created this amazing dashboard that is publicly accessible, where they looked at the logs of all the different downloads and outputted some statistics, and that was just on their website there. And this is what I'm going to be analyzing in the next few slides. One of the things that we can see is the geographical location of users. So here I'm showing for all the different continent, how much data was published, but also how much data was downloaded. So we can see Europe, really big publisher, and North America, really big downloader. Of course, we might be missing some of the Europe usage in these institutional copies. There are a lot of nodes that are hosted in Europe and that people use directly as a data pool, so that are not really captured. Uh, but that gives us a general idea of where people are. We can also look at the popularity of download of different experiments through the different MIPS here. And we think that's a useful thing to look at, for particularly with CMIP 7 coming up. The different MIPS can go and see which one of their experiments were more downloaded or less downloaded, and how that can affect what they want to do in the future. The next thing we can see is also the popularity, well, not really the popularity, but just the number of downloads for each models. But here we are starting to run into some problems in the data because there are two metrics that we can look at. We can look at the total size of downloads, so like in gigabytes, but we can also look at the number of downloads, meaning the number of files. But here there are no formatting requirements for model in CMIP, and so we have a lot of variability. For example, EC3 Earth is uploading their data 1 file per year, whereas a lot of other centers are uploading 1 file for like 150 years. And so when you're counting the number of files, it's basically the same data, but you're going to have a big factor for EC Earth that are really going to boost its number. Another reason of the popularity of EC Earth here is that they just upload a lot of data. If you upload a lot of data, then there'll be a lot of downloads, right? So it's a little bit difficult to be comparing all the different centers. We have a little bit of a similar problem when we look at the most downloaded variables. Here I'm showing the top 10. But another layer of complexity that we add is that the different variables can be influenced by the time resolution. So if we have 6 hourly data, of course, that's going to be really, really a lot of data. So large amount of gigabytes, but a few files. We can also look at the horizontal spatial resolution or the number of vertical levels. So if you're in the ocean versus the atmosphere, you have different number of level. It's a little bit to see. Now we have download, but what is used? We want to get to usage, what is like useful for people. But one of the idea we had for this to try to standardize this data is to divide the total size of downloads by the total size of uploads. Of course, this is not perfect, but this can give us an idea of how much people want this data. And when we did this and we look at the distribution for all the variables, we saw that a quarter of the variables, so not a quarter of the data or the size, but just like each variable, a quarter of individual variables, have an R that is below 1. This means that this data, this variable, is uploaded more often than it is downloaded. In a world where we have to be a little bit careful about the storage that we have, the storage is racking up, and we want to be a little bit more conscious about that. This might be something that can be looked at if we want to optimize this. This is not the only thing we want to look at, but that can be like a piece of the puzzle. Up until now, I've only shown you data for ESGF, but now we'll get a little bit more into like the other sources. So here, I'm showing you the same top variables that I've shown before, but I've kind of flipped them on the side. So we have the top 15 variable on ESGF, and then here we have the bottom 15, so things that are not downloaded very often. And I'm adding 3 columns for Google, Amazon, and C3S, so Copernicus. And when we're in black, that means that this variable is available on these subsets. So we can see that for Google and Amazon, all the like top downloaded variables on GSGF are also available, but they also host some data that are very unpopular on ESGF. For C3S, they're missing a few in the top, but that was kind of to be expected. C3S only has monthly and daily data, so of course they're not going to have the 6 hourly, but they also don't have some of the ocean variables that are very popular, but they also don't have any of the really unpopular one. So here I'm showing the top 15 and the bottom 15, but there's a lot more variable than that. So I'm going to be zooming out. And so we can see that it's more dark in the top. So in general, they are hosting things that are popular on ESGF, but they could like look a little bit more in the future if we want to know what to include in a subset. That would be an interesting to look at. But one thing to keep in mind is that there's also a possibility that the users of all these different sources are not the same users. So, and they maybe don't want the exact same variables. One thing that we can look at to try to understand the usage from these different sources is where people are coming from. And so here I'm showing the top 10 country users for ESGF versus the ones for Copernicus. And what we notice is that if you are a top user for ESGF, you're more likely to be from the global north, whereas if you're a top user for C3S, you're more likely to be from the global south. And then we have the big countries that are like top in both tops. One of the hypotheses that we have for this is that when you download data from Copernicus, you can subset the data before downloading it, which you can't do on ESGF. So if you have a little bit less resources and you can't host massive amount of data, going to C3S might be like really helpful to you. That's just a hypothesis though. Another way to try to understand the different users is to look at the sector they are coming from. And C3S has this data for its users. So the research and education sector is really the top one. That's not really surprising. That's like where CMIP comes from and is mostly being used by. But we can also see that there's a lot of users that are using it for commercial activities. Unfortunately, this data doesn't exist for any of the other sources, so we can't really compare the difference between the sources. So that was just like a sampling of some of the results that we have. And from that, in our report, we have some recommendations, some lessons that we learned from doing all this research. So one of the recommendations is that there's a possibility to optimize the storage for the less downloaded variables. So those that are in a R minus R less than 1. Obviously, some variables might be less popular, but very, very scientifically important for a specific question or very important for a specific group of users. So we're not saying like to like just use this to decide what to do with those data, but that can be part of the puzzle to see how to optimize best with all the work also that the data request people are doing. Another idea would be to prescribe the formatting of the data. That would be really helpful to do a kind of comparison of the different models in the future to do this figure in a kind of a better way. It's also as a bonus, it would be helpful for a lot of users if all of the data that we got was in the same formatting, just in general, would be helpful. And finally, that when in the future we're creating subset, looking at what was popular on ESGF can be a clue, but maybe on top of like what your specific user might need, but using the ESGF download stats might be cool for a future subset. In this project, we wanted to look at the usage, but what we really got was just download, which is kind of a step below. And there's also a lot of download that we were basically not able to do. There was a lot of ideas that we had at the beginning of the project that the data just like doesn't exist really. So we're also doing a list of the statistics that we think would be useful to gather in the future for CMIP 7. So for example, the cross-variable download stats. So right now we were able to look at like the downloads for a variable for all the models and all the experiments. But what if we could look at a variable for only one model or one experiment? We would be able to do more targeted analysis. Our next proposition is to have stats on the user sectors. that would help us understand the difference in the different sources and who really is using CMIP data. And finally, just more statistics on cloud sources, on institutional archives, and on downstream data set. You can see all this and even more on our paper that was recently accepted in the special issue for CMIP 7 in GMD. Please go see that. And I also wanted to say that this project would have like never happened without the Fresh Eyes community. We were people who didn't know each other, who just came together because we were interested in this project. And now we have this cool paper that hopefully can be useful for the community. And also it was a really great learning experience for us. So I would encourage any early career scientists to just join, or if you know any early career scientists, like encourage them. Just joining is really easy. There's like no barrier to entry, and you get to be on the mailing list and join the discussion platform. And then we'll send you the projects that are going around. And then when you find one that interests you, you can sign up. Or even if you have an idea, you can propose a project, and the steering group will give you some feedback to help you and put you in touch also with other members of the community. So a great time all around. Thank you.
Thanks a lot, Julia. That was really great. There's quite a few people here from ESGF, so I'm sure some of them might have a question. Has anybody got a question you want to ask Juliette before I dive in with one? Well, okay, I'll start then. So just reading between the lines of this, one thing that's just coming up recently is this idea of repacking CMIP6 data. So what we see from what your results are kind of showing is that it would be very beneficial for that type of exercise to really identify data that's regularly used or has been used a lot, and only focus on that from a repacking point of view rather than looking at everything.
Well, for sure, like I think in CMIP 7, it's going to be a requirement for everything. But I think for CMIP 6, it's like more complicating what we want to repack if we want to repack. So this could be a kind of, could help us choose only some, if we only want to repack some things, then we could look at this type of data to choose, what to prioritize.
There's also a question here from Kwame. It says, great presentation, Juliette. Do you have any hypothesis for the low download or usage of these CMIP variables in certain parts of the continent, such as Africa?
Well, I think that's a problem, that CMIP is like a very tight-knit community, and sometimes it's difficult to like get the data out there. There's also, like, if I'm not mistaken, no center that publish data in Africa also. So I think the communities are less present in these parts of the world. But I think we would hope that this data can be used everywhere, right? And Fresh Eyes actually has kind of a sub goal, like we want early career researchers, but we want also a lot of inclusion from people from the global south. And hopefully, if we get a lot of young researchers from Africa, they can also help us understand better why things are not downloaded, what could be done to help people get access to this data that need it. Yeah.
Forrest's got a question. Go ahead, Forrest.
Thanks. Great presentation. I really enjoyed that. I was going to point out that you may have gone back to some of the original data to figure out what the most popular variables are, but that CMCC has recently reprocessed some of those statistical downloads to do a more careful job of eliminating these partial downloads, which show up in some of the statistics. So for instance, the theta Oman, which bubbled up to the top in your top 15, is not really in the top most popular downloaded variables. It's just some of those ocean ones are just really big 4-dimensional variables. And so they take multiple attempts for anybody to be able to successfully download them. And so then each of those appears as a new download if you don't look at the offsets for the HTTP transfers. So that makes the problem a little more complicated, but I think everything else is pretty much the same. I think on their website, which I'll post here, for CMCC. I think this is a closer representation of the more popular variables, which kind of makes sense from a more atmospheric perspective. And so it doesn't invalidate any of the analysis you've done. It's just a quirk of the way that some of those data appear in the raw transfer logs.
That's interesting, and all the code for this is all available, so it should technically be pretty easy to redo all the figures with the new things. At some point in the project, like a year ago, we needed to say like, this is where we're stopping because this data is always changing, right? And so we had to say we're doing the analysis on this, and I think at that point they had also just said like, oh, we've identified a few mistakes and we removed them, so now is a good time. But of course we keep finding things, so
it's a moving
but good
target,
to know.
Sure.
Yeah. Thanks for your comment.